Hello, my name is Thomas Dick and today I want to talk about grips. So I use grips to hold specimens in the test frame, and so I need different types of grip for different applications. My most liked grips at the moment are the pneumatics I have, and today I want to talk a little bit about different advantages and disadvantages of grips. So I'm going to make a matrix, in fact, and on this matrix I want to say there are different applications, and I put soft materials. Could be something that could be important. There could be high temperature. There could be tension and compression. Versatility. So this could be some criteria that we see doing tests. So soft materials, that could be rubber. If you apply a strain on rubber, the tabs might reduce in thickness, and then if you have the wrong grips, the specimen loosens and you can't actually measure the specimens. High temperature, if you measure inside a temperature chamber, then you have a soft setup with rods, grips in there, and again, the material behaves softer, so you can have some soft material problems. High temperature means the grips need to withstand high temperature and need to clamp. Tension and compression, there are two aspects. One is if you do cyclic tests, tension compression cycles, then you want to have a smooth transition from tension and compression without any hysteresis or grip-induced hysteresis or gap or so. That's one thing, and the other thing is tension is fine, but in compression you need to have grips that can really do tension and compression. Okay, versatility would be nice to have one set of grips you can use for any kind of specimen and thickness and width and so on. That would be nice, but that doesn't always work. So what kinds of grips I want to talk about? I believe there are some important classes of grips. There are such vise grips. They look like this. Looks like a U. And then you have these plates in there, and you can open and close them using screws. Looks like that. Opening, closing. That looks massive, right? They are massive. Then there are wedge grips in general, and these are pneumatic wedge grips. So the pressurized air enters here, you need a compressor for that, and it moves a cylinder that can be seen here. That's where the cylinder goes to the two wedges. So these are two wedges, and if the cylinder moves up, then the wedges close, and if the cylinder goes back, then they open again. So these are nice because if you can be quite sure that you always have some closing force on them, but I'm going to talk about that later on. Then there are pneumatic ones. No, these are pneumatic ones. There are hydraulic ones, and that's a bit similar. Only that you use not air but oil. There are other delicate details and differences between grips. There is one thing I want to mention, that is when you close the grips, then for plastics and composites, soft materials, it might be important you don't induce a stress while closing the grips. So you put a specimen and you apply the grips, but you don't want to apply a badly controlled tension or compression to the specimen. And for that, it would be nice if nothing happened when you closed the grips. For wedge grips, that's not the case, because basically for these grips, the wedges move up, so you risk to induce a compression on the specimen when you close. But modern test frames can hold stress zero, so if you use that feature, then the test frame will compensate for the movement of the grips and you are safe. But I believe, especially for older machines, that was an important feature. So there are actually grips where you close wedges, but the wedges stay in the same position, and actually the head of the grips move up and down. That exists too. We have such MTS grips. Okay, so let's talk a little bit about these grips and relate advantages and disadvantages to this matrix. So let's start with the Weiss grips, then the pneumatic grips, and the hydraulic grips. So, who can deal well with soft material? Weiss grips, soft material. That's actually not working so well, because as I explained before, you tighten the grips and then they stay where you put them. So if your specimen elongates and it gets loose, there's nothing you can do about it. So actually soft materials, Weiss grips, let's say there is a minus here. Pneumatic grips, that one is good, because pneumatic grips, they you can apply pressure. So if the pressure gets reduced, or if the specimen elongates, the grips will close. So that's a plus. And the same applies to hydraulic grips, because the difference is mainly the media. High temperature in Weiss grips. Yeah, I would say, let's put it neutral, or let's say it's even positive, because Weiss grips, there is no media in there, and you can just use them at elevated temperature. That works. I believe that can be an advantage for high temperature metal tests even, compared to hydraulics. And that's now the minus for hydraulic grips here. Because for hydraulic grips, the oil is going to limit the temperature. So if oil goes up to 150 degrees C, then that's the limit of where you can go. And that's even for plastics, that might be too low. And for metal, for sure, that's not sufficient. So hydraulic grips have a disadvantage when it comes to high temperatures. And there are actually hydraulic liquids that go to higher temperatures, but still I haven't heard you could go to 200 degrees C. Pneumatic grips, that's an advantage of them. Air just gets hot, nothing happens. You can use them at high temperature. But the disadvantage of pneumatic grips is you can't apply very high stresses easily, because you tend to need bigger grips. Tension and compression. For tension and compression, the screws, I actually bought them for that. Of course, what I can do here is I can close them, and if it's a rigid plastic, that's something I want to do with that, then I close it. The rigid plastic is not going to do much, and I can go in tension as well as compression. So that's where I see a plus. For pneumatic grips, I see a minus for mine at least, because for the grips I have, they close using pneumatic energy, but the main force, the main closing force is actually done by friction and self-closing of these grips. When I apply a tension, then by friction it's gonna translate into compression. So that's the main closing force for these grips. I believe that can be different for hydraulic grips that have a very strong closing force, and where you maintain even a position can be better. But for pneumatic grips I can't go into compression, so there is a minus here. And I believe for hydraulic grips, at least the MTN ones I know, they can do that, so I put a plus. Something else I want to mention: if you go into tension and compression, then as I mentioned before, you want to minimize hysteresis coming from grips. So for example, in this case, when you do tension and compression, then these pads will go a little bit up and down, and this will add some hysteresis that comes from the grips. Something especially to remember when you want to make use of your crosshead position instead of a strain measurement. So it's better to do strain measurement if you do cyclic tension compression. I believe my favorite grips for doing that kind of cyclic tension compression testing would be hydraulic grips. Then versatility, I'd say I'm pretty happy with my pneumatic grips. They are pretty versatile. But I have actually different wedges, because I need to use different wedges for different specimen thicknesses. I believe that these vice grips, they should be pretty general actually, because they are very wide, and they are you can open and close them. Thickness, I believe you can use almost any thickness. So I would say they have some 2 pluses. And for hydraulic grips, I would say maybe similar as pneumatic grips. So, right. So that's my comparison of different kinds of grips. Thank you.